Welcome to Maths for You channel. Another past question. This question more into algebra and bit of differentiation. There's a diagram given. For a cone with a base radius r, the height h, and slant height l, the following formulas are given. Curved surface area S equal pi rl, and the volume V equal 1/3 pi r squared h. The container is to be designed in the shape of an inverted cone with no lid. The base radius is r, and the volume rm, and the volume is v meter cube. The area of the material to be used for the cone is 4 pi meter squared. So the area of the curved material is given 4 pi. Show that V equal 1/3 pi square root of 16 r squared minus r to the power 6. Let's write down some of the equations or formulas being given. S equal pi rl, so the curved surface area is, or the material used for the cone, S equal pi rl. That is again is given 4 pi meter squared. V equal 1/3 pi r squared h. V is the meter cube is the unit of volume. Prior to go further, let's look at that V equal what we been asked to prove. It's in terms of R only. So if you look at V here, 1/3 pi r squared h, so we need to eliminate A. But to do that, if we look at the cone and think of three-dimensionally, we can see a right angle triangle there with the functions h is the height, r is the radius, and l is the hypotenuse. So using the Pythagoras theorem, h squared equal L squared minus r squared. So h is square root of L squared minus r squared. Let's go to that volume formula. V equal 1/3 pi r squared. Instead of h, we can use the value which we have found, square root of L squared minus r squared. Again, the pi rl is 4 pi. That's the information given to us. So pi rl equal 4 pi. Pi cancel both sides. L equal 4 over r, because we don't need L, so we need to eliminate L as well. So L here 4 over r squared. Now go back to that formula again. V equal 1/3 pi r squared. The root L squared, instead of root L squared, we can put inside the root 16 over r squared. 4 over r squared is 16 over r squared minus r squared. Do a bit of algebra. 1/3 pi r squared inside the root 16 minus r to the power 4, r squared r to the power 4 divided by r. Then the denominator, r squared in denominator, if you could take it out of the root sign, that will be 1/3 pi r squared divided by r inside the root 16 minus r to the power of 4. R squared, r cancelled out. So what we left with, 1/3 pi r square root of 16 minus r to the power of 4. From that, V equal 1/3 pi. We have to take r inside to prove what we've been asked to prove. So if the r go inside the root, it will be r squared. So 1/3 pi 16 r squared minus r to the power 4 times r squared is r to the power 6. That is exactly what we have been asked to prove. So part A done. Part B, in this question, you must show detailed reasoning. So we need to explain certain things. We will deal with it when we come to that situation. It is given that V has maximum value of certain value of R. So what is it here? V in the form of R. So you can see V is variable and R is a variable. V with R will be dependent, variable, dependent variable. So in other words, when R changes, V change. Right, V maximum. So they're talking about maximum, minimum. Wherever they talk about, or someone talk about maximum, minimum, it's a turning point. So what we know at a turning point is the differentiation of the function with respect to the variable will be 0. So here, dv over dr equals 0. So that is what we have to start with. So dv over dr, if we differentiate that, 1/3 pi, I have written the square root of 16r squared minus r to the power 6, direct differentiation. It's like if you have square root, and if you differentiate that square root d of dx, that will be 1 over 2 root x. So if we could think of that, what is inside inside the bracket, we can think of an x. So 1/3 pi, 1 over 2 root, so like a 2 root x. But we need to sort of, not sort of, we have to differentiate what's inside the bracket because a function of function. So 16r squared, so 16 times 2r, r squared, differentiation of r squared is 2r, minus r to the power 6. That means 6 times r to the power 5, the power reduced by 1. Let's simplify it. 1/3 pi, the denominator, 32, 16 times 2, 32r minus r to the power of 5, divided by 2 times square root 16r squared minus r to the power 6. But at the turning point, doesn't matter where, the turning point always is 0. The differentiation at a turning point is 0. So dv over dr is 0. If it's so, 1/3 pi, 32r minus r to the power of 5 divided by 2 times 16r squared inside the root minus r to the power 6 equals 0. Let's take the constant out, say 1/3 pi, and then divide by 2. So 1/6 pi, 1 over 6 pi, it can't be 0. So that is not equal to 0. So what can be 0? 32r minus r 6r to the power of 5 divided by square root of 16r squared minus vr to the power 6. Again, if we could take r common on the top, 32 minus r to the power of 4, r time in bracket 32 minus r 6r to the power 4. And here, the denominator, if you could r squared out of that root sign, square root sign, that would be r. So inside, 16 minus r to the power 4 equals 0. So r cancel. And now we have 32 minus 6r to the power 4. If you look at it, fourth order equation. So obviously, we expect 4 different values for r. But do we need to, or do we get all 4 values? We'll see. That is what we need to give reason to eliminate certain values. Right. R to the power 4 is 32 over 6, which is 16 over 3. The r squared is plus or minus 4 over root 3. But r squared cannot be as negative sign. So therefore, that is only the positive value. So r squared equal 4 over root 3. Then r equal, so root of 4 over root 3. Again, plus or minus 2 over this is 3 to the power half and another half, so half times half is 1/4. So 2 over 3 to the power 1/4 plus or minus. But r is a physical value, so cannot be negative value. So minus gone. So our only value we have 2 over 3 to the power of 1/4. So that's the value. This is what we have to explain. That's what they said to give all the reasonings. So now we end up with r equal 2 over 3 to the power quarter. That's it. Let's put the values. This with the value, we need to find v. So v, all we have to do is just v equal 1/3 pi 16r squared minus r to the power 6. So all we have to do is just to substitute that r value here. So 1/3 pi, the square root inside the square root, 16 times r squared. 16 times r squared is 4 over root 3. If you square that 2 over 3 to the power quarter, it will be 4 over root 3. That's what it is. Minus 6 times. So 4 over root 3 is squared. So r squared is 4 over root 3 to the power of 3. And purely now just use the calculator and find the value inside the root and then multiply by pi and divide by 3. We have this value. So I just use the calculator to end up with this value, 5.197. But the question asks, find the value of container R, find the maximum value of V, giving your answer to correct, correct 3 significant figure. So that's what significant figure. So we need to bring it to, so to significant figure, so 7 come to the 9, that will be, so 19 will be 20, so 5.20 meter cube. That is the answer for that question. Thank you.